what do you get for that $100? We did an independent study, and this is actually commissioned by the regional state commissions or the state commissions and the SPP, and it determined that it had essentially 270% ROI for its SPP services over the next 10 years. So even though it's costing money for us to operate, we're providing much more value back to the users of the transmission system and ultimately the ratepayers. Okay, let's talk a little bit about the grid. SPP is part of the entire grid. The grid is connected all the way, all over the United States and up into Canada. It's all big one synchronous grid. It's been called the largest machine in the world. It operates simultaneously. You can go from the wall receptacle right here and go anywhere in the United States and Canada without leaving the wire. It's all connected together. Importance of electricity. Electricity amounts to nearly 50% of the energy consumed in the United States. It is a major energy, it's a major economic motivator for the country. We use electricity. It's a very efficient, very clean, it's very flexible. We can do a lot of different things with electricity and use it in a lot of different locations. And certainly lack of electricity, if you've ever been without electricity, it not only causes inconvenience at your homes, but it significantly impacts industries as well. In 2003, when the blackout occurred, they had said it cost millions and millions of dollars for every hour that the entire grid was out, and lack of production for the United States. Here's a list of some common terms. I probably won't go through all of them, but the important thing is that I want to highlight is just the how we get electricity, or the watts. It's a multiplication of current and voltage. So if you increase your voltage, you can reduce your current to get the same amount of power. And that's a concept I'll show you in a little bit. And then when we talk in watts, kilowatts, megawatts, it's all watts. It's just a different amount of electricity. Instead of 1,000 watts, we have 1,000,000 watts. And then when we say watt hours, it's the time value of the electricity, using it for an entire hour period. A couple other terms for you. Capacity. This is essentially the rating of the unit, the rating of the generator. It's similar to your car. If your car is rated at 200 horsepower, well, it doesn't always run at 200 horsepower, but in some conditions, if you, floor it all the way, it's capable of producing 200 horsepower. The same way with our power plants. Our power plants have a rating, and we call it a capacity rating, but they don't always run at that level. And electric load is just the amount of power delivered to the system. It's what the demand is, or what the people are requesting to be used. Electricity is strictly based on demand. When you flip that light switch, the utilities are monitoring it constantly, and we sense the need to ramp up our generation. So we are responding to what the customer's needs are. We don't have a way to tell you to go turn that light on because we're going to ramp up the generation. We're strictly load following and responding to what the customer's needs are. If you look down there in the corner, you'll see my little graph on the bottom side there. On a typical day, we'll have a different load profile. Where in the morning, everybody wakes up, they turn their lights on, the demand increases. It kind of backs off a little bit, then we get a noon or lunch hour peak, and then it'll normally go down a little bit, and then in the evening we get the largest peak, especially in the summertime when everybody comes home and turns the air conditioners on, and it's the hottest time of the day. So that's what we call our daily load profile, and the generators and the planners have to be able to respond to that change. A couple terms in generation that are important. You may hear the term baseload generation. Baseload is generation that you essentially put on and run at the same level all the time. And it's baseload in that the total electricity demand never falls below that level, so you never need to back it down. If you take a state of Nebraska, let's say we're operating at 5,000 megawatts, well, we may have a cycle between 3,000 and 5,000 megawatts during the day. That means that our base load, we need 3,000 megawatts of base load, and then we need 2,000 megawatts to be peaking or load following, where it's going to fluctuate during the day as the load goes up and down. And that's some of what you see there in balancing. You know, we're required to balance the load versus supply. And that's something that's done very, very proactively to make sure that we maintain a nice steady system. Okay, transmission, which is what we're here to focus on. Transmission is one of the neat things about electricity is we use AC or alternating current, and that allows us to transfer voltage levels or change voltage levels so that we can have smaller wires carrying a lot more power. In my example here, I've got a 1-inch copper bar, and if you were looking at 20 megawatts and trying to run 20 megawatts through it, you need to have a 1-inch thick at 18,000 volts. But if we change the voltage and put it on a 500 kilovolt line or 500,000 volts, our amperage goes down to 40 amps with the same amount of power, the same 20 megawatts. And that's what we use the transmission for. We step up the voltage, we can run a lot of power through smaller wires, distribute it to where the load is, and then we drop the voltage down so that you can run in your house. And in your house, you want a smaller voltage so it's a lot safer for the people so you don't get shocked. If you had 500,000 volts, you couldn't be very close to it at all. And that's why our receptacles in the home are usually 120 volts so that we can use it safely. When we talk about distribution system, distribution for us is the lines and equipment that you see in your neighborhoods. Those are the transmission lines that are typically running down your streets. And you'll see pole-mounted transformers like this. Those are very common. That'll be used to step down to deliver to a house. So that'll step down to the voltage that you use at a house. You may also see these big green things on the ground. Those are pad mount transformers. That's for underground electric service, and where we'll run the power into those transformers and step it down as well. And here's just a quick schematic showing you how it all happens from start to finish. We start with the generator over here. It generates a little bit of electricity, runs through the transformer, steps it up to the transmission line voltage. Our amperage is very small when we go at 500 kV for this amount. Distribute it to the neighborhood. We step it down to what we call a distribution voltage, and in this case it's 13 kV or 13,000 volts. And then we'll run it down the street. We'll put that little pole-mounted transformer there, and we'll drop it into your house at 240 volts or something that you can use every day. So that's the process on transmission. You'll see how transmission is such a vital part of it because it not only allows us to transfer power distances, but allows us to put the generation in remote areas. You don't have to put the generator downtown Lincoln, Nebraska. You can put it out in a remote area. So you've got the facilities that you need for cooling. You can have a coal pile if you want to burn coal, or whatever you need for the power plant. You can move it outside of the heavily populated area. Okay, any questions on what I've covered so far? Yes, ma'am.
I have to do this to be even-handed, but you had an incandescent bulb on one of your first slides. Do you think you could change that to a CFO?
That's a good point. I will make that note.
Thank you.
We need to upgrade our slides.
Yeah.
Yes, ma'am.
I have kind of a strange question. You had a table that showed percentages of electricity that were generated by different things like coal and hydro and so on. And you had an other.
Yeah, I would do that.
What's other?
Yeah, what is the other?
Thank you.
The other could be a diesel generator.
Oh.
It could be some other. I know we've got at least 1 or 2 facilities that